Good evening, everyone. Many of
Good,
them
good
are
evening, ma'am.
active in the chat box, not in the screen. It's okay. Fine. I warmly welcome to all of you for this today's session on engineering application on data analytics. It's quality control and defect analysis. In today's engineering environment, the quality is no longer just about the final inspection or checking the defective products. So, with the advancement of technology, the engineers are expected to analyze large volume of data generated from machines, process, and systems to ensure constant the consistent quality and reliability. So every day the manufacturing plants or process in industries, especially the engineering involved in this system, so they generate massive amount of data. So however, the data alone does not improve quality. It's insights from data do. So that is where the data analytics plays a very critical role here. So in this sessions, we will explore how the data analytics is applied in real engineering scenario, in especially to monitor the quality, identify the defects. So we will also discuss some practical tools, analytical techniques, and industry's case examples that are relevant for modern engineers. Yes. The session objective is the first we can see the understand the role of data analytics in quality control. The quality control in engineering is no longer limited to manual inspections or end product checking. So that today the huge volume of data are generated from machines, sensor, inspection systems, and operators. So in this sessions, we will understand how data analytics helps convert this raw production data into meaningful insights. We will see how analytics supports continuous monitoring of process, yearly detection of variance, and prevention of quality failures. So by end of these sessions, I mean, you will should clearly understand why the data driven, it's involved in the quality control is more reliable. It's compare the traditional methods, it's more faster as well as that cost effective also. So these things clearly you just to be understand. Second one is how they learn how defects are identified and analyzed. The defects can occur due to machine issues, even the process variance, then it's material problems, even the human errors also, maybe the defects can occur. So the simply detecting a defect is not enough. So the engineers must understand why it occurred. So in this sessions, we will discuss how defects are identified using inspection data and process parameters, and how the analytical techniques such as defects classifications, trends analysis, it's it's especially R chart, root cause analysis help the engineers trace the source of problems. So you will learn how the data analytics shift quality control from reactive inspections to proactive defects prevention. Then next, explore the engineering case example. To make the concept practical and easy to relate, So we will explore real engineering case examples. So from manufacturing, some electronics and process industries also, how the data analytics is useful. Then these examples will show how the companies use the data analytics to reduce the, especially to improve the quality control as well as reduce the defects rates. So the goal here is not just the theory but also helping you visualize how these techniques are applied in real industrial environment. Then finally gain practical insights into tools and techniques. So we will discuss the tools and techniques commonly used by engineers for quality analytics. This includes basic tools like Excel and statistical softwares, as well as the advanced tools such as Python, then machine learning models, visualizing dashboards. So you will gain some clarity on which tool is used for what purpose and how these tools support to the quality engineers in decision making. So let's let us begin by understanding why the quality control is critical in engineering and how the data analytical part is strengthened its. So now we can discuss about the importance of quality control in engineering. First, ensure the product reliability and safety. In engineering, quality is directly linked to reliability and safety. So the small defects in a component can lead to system failure, especially safety hazards, even the loss of life. So especially in sectors like automobile, aerospace, civil and electrical engineering. So the quality control ensure that every product or components it's meet the required specification and performance constantly. So under real operations conditions, maybe the through systematic inspections and data monitoring, engineer can defect the variance yearly and prevent the unsafe product from reach to end users. The second important is it's reduce the rework, scrap and warranty cost also, because the when quality issues are detected late na, so they result in rework. So the scrapping of materials or warranty claims after the product reaches the customers, all of these significantly increase the operational cost, as well as that customers dissatisfaction also it's lead to the brand names, right? It's affected directly to their brand names also. So these are the things we want to be decreased. We can properly use their data analytics. So effective quality control supported by data analytics helps the identify the problems at on early stage. Then so this minimize the waste, reduce the rework cycles and lower warranty and service cost also. If simply says now, the preventing defect is always cheaper than the fixing them later. So then third one is it's improve the customer satisfactions. So the customers today expect high quality, reliable and consistent products. The poor quality control ensure the customers receive the product that meet their expectations every time. So when defects are minimized, so the performance is constant, the customer satisfaction also increase. So this leads to the repeat business and positive brand images also. So the data driven quality systems it's help the organization maintain this consistency at scale. Then finally support compliance with standards. even ISO, Six Sigma. So the engineering organization must comply with quality standards such as ISO 9001, ISO even 14,000. Some methodologies, yes, like Six Sigmas. So these standards require the documented process, measurable quality metrics, and continuous improvement. How our educational institutions we are expecting some accreditation, na? NAC or NARF ranking is there or not. In if you go for accreditations, NAC, na, it's A plus plus. So that much of things we are expecting. Our institute having their AMBA, that is also one of the accreditations. So that in based on their accreditations, we just to be calculated in the institutional uh, I mean institutional standard, right? So in organization, you know very well about that, the ISO 9001, ISO 14,000, then the companies full-fledged used for Six Sigma. So these are the things, it's the customers understand the companies having their standard. So the data analytics further strengthen the compliance by offering the traceability, the process capability analysis, and continuous performing monitoring. So therefore, the quality control is not just the technical requirement; it is the necessity that ensure the safety, cost effectiveness, customer trust, and compliance in modern engineering also. So now we can discuss what is data analytics. Now you know that in every sectors, even especially not only engineering, even that trade and commerce also normally included in the data analytics, because the reason is, yes, after the technology interventions, the customers expectations, so lot of impacts, the lot of reasonable reasons is there to behind why we are keeping the data analytics in our business nowadays. Okay, so first we want to be understand what is data analytics. That's why you know that in many MBA colleges also, it's previously the finance, marketing, HR, operations, that much of hospital management, hospitality, the tourism management. So that much of specializations only involved in the MBA. Right now, nowadays, it's a very famous MBA specialized in data analytics, especially for the core analytics. If you take marketing plus analytics, na, so marketing analytics, then HR plus analytics, HR analytics. So that much of finance plus analytics, finance analytics. So that much of every field, the analytics intervention is nowadays expecting for the corporate world. First, we want to be understand what is data analytics. First, it's a process of examining data to extract the insights. The data analytics is the systematic process of collecting, cleaning, and examining the data in order to discover useful pattern, trends, and insights. In engineering environment, large amount of data are generated every day, from even machines, sensor, inspection systems, and production logs. So by analyzing this data, the engineers can understand what is happening in the process. So identify the abnormalities as well as the improvement performance. Then use the statistics, algorithms, and visualization. So the data analytics combine multiple techniques such as statistical method, mathematical algorithms, and data visualization. So the statistics help us measure the variation and understand the process behavior. So the algorithms help identify the patterns or predict the outcomes, and visualization tools such as chart and dashboards make the complex data easy to interpret. So together these techniques allow engineers to move from numbers to meaningful engineering insights, then convert raw protections into its decisions. Production data, why hiding their slides, I'm not understand. Yes. Okay. So the raw data by itself has little value unless it is converted into actionable decisions. So the data analytics transform machines reading, inspections values, and defects counts into decisions such as adjusting the process parameters, stopping a machines, or improving a design. So this enabled the engineers and managers to make objectives, data driven decisions, instead of it's relying only on experience institute. So then foundations for industry 4.0 and smart manufacturing also. The data analytics is a core pillar of industry 4.0 and smart manufacturing. So the technologies such as IoT, automations, artificial intelligence, and digital twins, it's rely heavily on data analytics. So without analytics, the smart machines cannot predict the failure. So the optimize quality or adapt the process in real time. So therefore the data analytics act as a backbone that connect the digital technologies and engineering decision making. So now that we can understand what data technology is, let us look at the different types of analytics used in the quality control and defects analysis. First one is descriptive analytics. That is what happened. The descriptive analytics, it's mainly focused on understanding past events. In quality control, this includes analyzing the historical production data, defects counts, inspection report, and rejection rates. Example includes monthly defect percentage, its average process output, or number of rejected components. So this type of analytics provide a clear picture of current and past performance. So forming the foundation for future analytics or further analytics also. Further analysis or further making some calculation, it's helpful for us. Then diagnostic analytics. That is means it's why it is happen. Diagnostic analysis, it goes one step deeper and try to identify the reasons behind defect or variations. That the engineers use the techniques such as root cause analysis, it's a correlation analysis, and cause and effect diagrams. So for example, diagnostic analytics may reveal that a rise in defects is linked into specific machines operator shift, especially the temperature variation. So this helped the engineers focus on the real cause rather than just treating the symptoms. Then predictive analytics, that is what will happen. The predictive analysis uses the historical and real-time data to forecast the future outcomes. In quality control, the predictive model can estimate the probability of defects, predict the equipment failure, or that's it's identify the badges that may fail inspection. So the machine learning algorithms and statistical models are commonly used for this purpose. So this enables organization to make preventive actions before quality issues actually occurs. So the predictive analytics, what should be done? The prescriptive analytics, that it's a prescriptive analytics, it's provide the recommendation on the best possible actions to take. We can simply say that it's based on the predictions. The system may suggest adjusting process parameters. It's scheduling the maintenance or stopping the productions to avoid defects. So this type of analytics, it's support automated and intelligent decision making. So which is essential in smart manufacturing environment. So this prescriptive analytics is more helpful for them. So these four type of data analytics works together, from understanding the past to recommending the future actions, especially making the quality control and proactive and effective. Then uh, data sources for quality control, that is, yes, first the sensor and machine data, IoT. In modern engineering systems, the machines and equipment are fitted with a sensor that continuously collect data such as its vibration, speed, temperature, pressure, and cycle time. So with the use of IoT, this data is transformed in real time and stored for analysis. So the sensor and machine data help the engineers monitor process stability, detect abnormalities yearly. We can easily detect. So and identify the conditions that may lead to defects or equipment failure. So this form the backbone of real-time quality monitoring in smart manufacturing. Second, inspection and test report. The inspection and test report, it's provide the direct information about the product quality. These include especially for dimensional check, functional test, even the visual inspections and final quality audit also. So this data help the identify the defects product. It's measure the defects rates, especially to verify the whether the product meet the specification. So by analyzing the inspections, the reports over time, the engineer can identify the recurring the defects and trends. So which supports continuous improvement initiatives. Then third one is process parameters. So the process parameters such as temperature, pressures, speed, and flow rate have a direct impact on product quality. Even the small variations in these parameters can result in defects or inconsistency. So the data analytics help the engineers study the relationship between process parameters and quality outcomes. It's enabling the optimization of operating conditions and reduction of process variation also. Then operators logs and maintenance records. The operators logs and maintenance records, it's provide the valuable contextual informations as well as the machines alone cannot be captured. Excuse me. Sorry. So these records include the details about shift changes, manual adjustments, machines breakdowns, and maintenance activities. So when compare with sensor and inspection data, they help engineers understand human and equipment related factors contributing to defects. So this integrated view supports its effective root cause analysis and preventive maintenance planning. So by integrating data from machines, inspection, process, and people, the quality control become more accurate, reliable, and proactive. Then defect analysis key concept. So defects versus defective product. First, a defect refers to a single non-conformity or it's a flaw in a product or process, such as scratches, dimensional variations, or improper assembly. A defective products, it's another hand, it's a product that contain one or more defects and therefore does not meet the quality standards or customers requirements. So the understanding this distinction is important because the quality improvement effort often focused on reducing defects, so which in turn reduce the number of defective products. Then critical, major and minor defects. Defects are classified based on their severity and impact. A critical defect can cause the safety hazards, system failure, or legal non-compliance and must be eliminated immediately. But a major defects affects the product performance or customer satisfaction but may not pose the immediate safety risk. A minor defects does not significantly affect the functions but impact the appearance or perceived quality. This classification helps the engineers prioritize the corrective actions and allocate the resource effectively. Then defect rate and defect density. The defect rate to the proportion of defective items. In a given production quality, it's often expressed as a percentage. But defect density measures the number of defects per unit or component or area, so in electronics, software and complex assemblies. Then these metrics help engineers, it's track the quality performance over time and evaluate and the effectiveness of process improvements. Then root cause analysis, simply we can say is RCA. The root cause analysis is a structured approach used to identify the fundamental cause of defects rather than treating only the symptoms. So the techniques such as the five whys, uh, we can easily say says na what, where, when. Yes, that much of things we want to be, we can say the technique. So how it was happen, when it was happen, what time we want to be rectify that issues, that is minor, major, critical. So all the things, that is root cause. So fishbone diagrams, the failure mode analysis are commonly used in the root cause analysis. Previously we can say is na, it's a defects or defective, it's a critical, minor, majority, minority. So that much of things we want to be analyzed, that root cause analysis also. Then root cause analysis, it's ensure that it's a corrective actions or permanent and prevents the recurrence of defects. So the data analytics strengthens root cause analysis by providing evidence based on insight instead of assumptions. So effective defects analysis help the engineers not only identify the problems, but also it's eliminate their root cause, leading to sustainable quality improvement. Then next we can see the analytical techniques for defective analytics. So first one is statistical process control. We can simply short we called SPC. That is, SPC is a method used to monitor and control the process using these statistical techniques. It helps the engineers understand whether the process is operating under normal conditions or it's a unusual variations. Then a statistical process control focused on identifying the assignable causes of variations before they result in defects. So by continuing monitoring process data, the SPC, it support yearly detection of quality issues and promote process stability. Then second one is control chart. In control chart we can say that X bar, R chart, P chart. So the control chart or graphical tools, it's used to the SPC to track the process performance over the time. For example, X bar chart, it's monitor the average value of process, but R chart, it's helpful for track the process variability, but the P chart is used to the attribute the data. So such as the proposition, it's of defective items. So when the data points fall outside of control limit, so all shows unusual patterns. So the engineers can investigate and take the corrective actions before defects increase. These are the statistical process control, that control charts. So these are the tools, it's helpful for analyzing their defects, right? It is it is some techniques, we can say it's normally we can call it as tools, right? Then Pareto analysis also, that is we can simply call it as 8 bar 20 percentage. That what is the meaning is the it is the based on the principle that roughly 80 percentage of problems, yes, are caused by 20 percentage of the causes. Okay, so the 80 percentage of problems caused by the 20 percentage of the causes. That is the meaning 8 by 20. So in defect analysis, these techniques help the identify the most frequent or impactable defects. So by forcing the improvement effect on the major cause, identify the Pareto chart, the engineers can achieve the significant quality improvement with minimal effort. So the meaning is the 20 percentage we can understand, we can rectify, automatically the 100% problem will be solved. That is the that time, that is the thing we can use for the Pareto analysis. Then regression and correlation analysis. So regression and correlation analysis are used to study the relationship between the process variables and quality outcomes. So the correlation analysis, it shows whether two variables are related or not. For example, in a researcher also normally using their regressions and correlations method to comparison of two variables. For example, age and income. To take age is one variable, income is one variable. The age as well as income having their correlation or not, we can check it. Yes, another thing is experience and income. Yes, the two variable, income is one variable, experience is one variable. We can compare the experience and the income, it's having their correlations or not. Yes, obviously, right? Exceptional cases of maybe is there, that is to leave it, but normally you see that 10 years of experience people got the salary, they will get it nearly 1 lakh. Yes, for engineering field. Maybe 15 years of experience engineers got the more than 1.5 lakhs. So that much of correlation. The experience will increase, automatically the salary will increase. That much of correlation is there, right? So the correlation analysis helpful for to compare the two variables. So the engineers can analyze how the temperature or pressures affect or defect. Temperature is one variable, pressure is one variable, right? So to compare the, automatically the temperature will be increased, automatically what about their pressure effectiveness. So these much of things we compare na, so automatically we can use their correlative analysis. So these techniques support the data driven decision making and process the optimization. So these analytical techniques enable the engineers to move from observation to insights. It's helping them control process and reduce the defects effectiveness. Previously, last slide, you know that this slide we can see that analytical tools, right? But this slide we can see that advanced analytical tools, right? Especially in the AI involvement. So the machine learning and for defective predictions. So the machine learning use the historical quality and process data to identify the pattern that are difficult for human to detect. But in quality control, the machine's learning models can predict the likelihood of defects based on inputs such as machine settings, material properties, and environmental conditions. So this allow engineers to take the preventive actions before defects the actually occurs. So reducing the rejections rate and improving the overall process efficiency. Second, computer vision for surface inspections. So the computer vision use the cameras and the images processing algorithms to automatically inspect the product surface. So it is widely used to detect crackers, scratches, then misalignment and surface irregularities. So the compared to manual inspections, the computer vision system are faster, so more accurate and consistent. So the data analytics enhances this system by continuously improving detection accuracy through learning from past inspection results. Then anomaly detections in real-time data. It's focused on identifying the unusual pattern or deviation in real-time process data. So these anomalies na, so may it's indicates the machine malfunctions, tool wear or abnormal operating conditions that can lead to defects. So by defecting anomalies yearly, the engineers can intervene immediately, preventing large scale quality failures and unplanned downtime. So then predictive quality analytics also. The predictive quality analytics combine machines learning, statistical model and real-time data to forecast the future quality outcomes. So it helps the predict defects rates, its process capabilities issues, and it's a product failures before they occur. So this enables the organization to shift from reactive quality control to proactive and preventive quality management. So, which is a key requirement of smart manufacturing. So, the advanced analytics and AI transform the quality control from inspection based system to intelligent self learning as well as the predictive systems. So the previously we can say that previous slide we can say that it's a manual inspection quality control technologies, techniques or tools. But this slide it's explained that advanced technologies tools, especially after the intervention of AI. So I'm just giving your engineering case example. It's for example taking their manufacturing field. So identify the root causes of assembly defects. So in a manufacturing assembly line, repeated defects such as loose fitting or its misaligned components are often observed. So using the data analytics, the engineers collect the data from IoT in sensor pattern, then assembly time, then operator shift or inspection results, everything we can get it. So by applying that, it's a Pareto analytics or root cause analysis, they identify that the specific workstation or shift contribute to most defective. So corrective actions such as it's retaining operators significantly, it's reduce the defects rates. So this shows how the analytics help move from assumption to evidence based problem solving. If you take automotive, it's predicting components failure rates. So in automotive industries, it's components failure can lead to recall and safety issues. So the manufacturers analyzed here for historical failure data, especially voluntary claim and sensor data from its tech vehicles. So the predictive analytics models estimate the probability of components failure under different operating conditions. So this allows the engineers to redesign the components, it schedule the preventive maintenance and reduce the warranty cost while improving their vehicle safety. Then electronics. In electronic manufacturing, the shoulder joint defects are major quality concern. High resolution cameras capture the image of shoulder joint, and computer vision algorithms analyze the shape, so the size and alignment. So the machine learning models classify joints as acceptable or defective with high accuracy. So this automated inspections, it's reduced the human errors, especially in the time of during their join the shoulder. Then process industries. In process industries such as chemical or some other industries is there na, some paramedical, yes, a manufacturing. So the quality depends on consistent control of parameters like temperature, pressures and flow rate. So the data analytics used here to monitor these parameters continuously and it's correct them with output quality. So the statistical process control, the predictive models help the identify the conditions that cause variations. So by optimizing process settings, the engineers achieve uniform product quality and reduce the waste. So these case example demonstrate how the data analytics is practically applied for across engineering domain to improve the quality, reduce the defects, and support smarter decision making. Then tools used in practice. So normally we having SPC, regressons, correlations. So any techniques. Yes, we can see that now previously. Yes, so all the things, whatever may be, we can see some advanced techniques also. We can see, yes, predictive quality analysis, even the anomaly defective, then it's computer vision, surface inspections, machine learning, regression analysis, control chart, whatever may be, right? But that we can use na, uh, what are the tools we can practically we can use. For example, Excel and advanced Excel. Without Excel and advanced Excel, we can't use those techniques in the frequent manner. That is the meaning. So here the advanced, the Excel, that is one of the most widely used tools. It's for quality analytics in industries. Without Excel, definitely you can't able to work in the data analytics fields. The same wise, the advanced Excel also. Yes, the engineers use the Excel for data cleaning, basic statistical analysis for pivot table chart and trend analysis. That is, we can use the Excel. But in advanced Excel features such as formulas, macros, especially it's a solver help automate repeatedly quality calculations. Advanced Excel formulas, that it's a powerful lookups, index, match, exclude, some connections, if errors. So these are the things we can use in the advanced Excel. So because of its simplicity and accessibility, the Excel is often the starting point for quality analytics. Second one is mini tab and SPSS. The mini tab, or even SPSS, or specialized the statistical software, especially these software used for frequently for researcher to find out their new things. Okay, so that time definitely the SPSS they are using. So they provide a built-in tool for statistical process control, especially hypothesis testing, regressions, and capability analysis. So that these tools are particularly used for engineers working in structured quality improvement and environment. So they reduce the manual effort and help the ensure the statistical accuracy. Yes, regression analysis, correlations, hypothesis. If everything go for manual, definitely it's occurred from some errors. Not for some, in many errors also it's possible. Another thing is statistical persons only can possible to do all the things in manually. But if use that SPSS na, so everyone, science background, especially physics background people, chemistry background people, arts background people, any peoples, even the history people also, history degree people also can be used for that software SPSS. Okay, so that is the thing of the advantage. That is the tool used for using their data analytics. SPSS, that expansion also, statistical package for social science, especially social science research peoples are using their lot in the SPSS. Okay, then Python or for analytics. Python and or are the powerful program language nowadays. Previously 10 years back, 15 years back, J, C plus, what are the language we can take now? We can only using for computer science engineering people or MCA people only can able to use their language, everything. But nowadays every people, any people, any discipline people are used in nowadays for Python are easily, because of that much of tools available now. Previously that much of tools can't. After AI intervention now we can easily to learn their language easily, but previously that much of uh, opportunities we couldn't, right? So these language use the advanced statistical analysis and machines learning, so they allow the engineers to analyze the large data, build the predictive models and automative quality analysis task. So these tools are essential for industry 4.0. What is that industry 4.0? Industry 4.0 is nothing. It's intervention of IoT, intervention of AI, intervention of robots. Yes, especially involved in the data driven technologies. That is industry 4.0. So then Power BI and Tableau for especially for creation of dashboard. So the Power BI and Tableau are data visualization tools. So it's used to create the interactive dashboards. So they help the engineers and managers monitor the key quality metrics in real time. So such a defect rates and process performance we can easily to see that. So visualized dashboards, it's improve the communications, enable faster decision making and support the management reviews also. So these tools are especially valuable in virtual and data rich industries. Then what is finally we can see, what is the benefits and challenges involved in the data analytics? First, they improve the quality and consistency. So the data analytics enable the continuous monitoring of process and yearly detection of variance. So by identifying the trends and root cause, the engineers can stabilize the process and reduce the defects occurrence. Then faster decision making. Traditionally, the quality decisions often rely on manual report and delayed inspections. So this data analytics and real-time dashboards, the engineers can access the quality incident or very instantly. Yes, I mean immediately. Then cost reduction also, to improve the quality directly lead to reduce the rework, scrap easily identifications, deducts we can easily identify. Then deducts also we can identify their variance. It's a minor deducts, defects or major defects or whatever may be, we can easily to identify. So based on that, the cost also should be reduced, no need for taking their much time. So the predictive analysis help the prevent the defects and the equipment failure before they occur. So these are the things involved in the benefits, but some challenges also is there. Yes, of course we agree that first challenges is data quality issues. The analytics is only as good as the data used. Maybe we can say na input process output. Suppose the data, we ensure that it's wrong data means, manipulated data means, definitely the outcome comes to manipulated. So that is the thing, incomplete, inaccurate, wrong data. So it can lead to incorrect conclusions and poor decisions. So ensuring the proper data collections, validations and standardization is the major challenges in quality analytics. Second one is skill gap. Implementing the data analytics, it's require the engineers to have a knowledge of statistics, handling especially for analytical tools. For example, SPSS, it is one of the software for using their uh, hypothesis, regression, correlation methods. We can enter the data now, within a second we can get the results. Of course, agree that, but we having their knowledge to use their software. So definitely we want properly, we want to use the software now, definitely we want to complete the software, at least the certificate courses. It will take for minimum 3 months. Okay, so that time we want to spend. Even that students, we can possible in side by side we can learn that much of software. What about that working people? Yes, if you entered our job career, so automatically we can updated all the things, right? After 6 months another one package, another one package will come. After 1 year another will package will come. So everything we want to update. If you want update, we need the time. Yes, but we can't say like that. Every time we having their time also, that is also it's question mark in that competitive world. So everything is, so we want to be sacrifice some of the jobs also, right? We take that some gap to learn, then again again we can find out the new job or new profiles. So that much of difficulties also is there. So it is one of the major challenges in the all the companies. If you take now, it's a skill gap. If you take in employees now, definitely it is the professional challenges also. Then integrations with legacy systems. Many engineering organization still operate with legacy machines and outdated systems. So it's integrating these systems with the modern analytics platforms and IoT solutions can be complex and costly also. So while data analytics offer these significant benefits in quality control, addressing these challenges is essential for successful and sustainable implementation. If we conclude that data analytics is fundamentally transforming the way quality control is performed in engineering, it moves the organization away from traditional inspection based approaches towards intelligent data driven quality systems. So, by analyzing the process and production data, the engineers can detect the potential defects early, even before they occur. So, this proactive approach not only improve the product quality but also reduce the waste, rework and operational cost. So the modern engineers, the data analytics is no longer on operational skill. So you know that it is on essential competency that support better decisions making, innovations and career growth in industry 4.0 environment. So finally the data analytics form the foundation for smart and sustainable manufacturing. By optimizing the process, reducing the defects and conserving the resources, it support both technological advancement and environmental responsibility. So we can summarize the today's sessions. The engineers who combine the domain knowledge with the data analytics, yes, will lead the future of quality and manufacturing excellence. Okay, thank you. So any questions from your side? It's okay, fine. I'm just giving here one suggestions. The engineers, in finally, I'm saying now, please kindly to learn some tools. Yes, because these tools helpful for you for given more knowledgeable person in your domain. Okay, we can express in your knowledge in a very systematic manner, in very respectable manners. For example, you having their engineering certificates, fine, up. attached with few certificates. For example, advanced Excel certificates, Power BI certificates, Tableau certificates, even R certificates, Python. These are the certificates only giving their value for your degree. For example, in engineering, what is the use of Python? So the large data you can possible to handling, so you can learn how we can handle the large data. Then predictive analytics and machine learning, everything you can get it. Then automation of quality analysis. So example, any manufacturing plant use the Python to protect the defective product by analyzing the sensor data such as vibration and temperature before defects occur. So these much of things, these much of certificates helpful, not only helpful for increase your or showing your knowledge, even side by side you are getting more package also. Thank you. You don't have any questions, please leave the sessions.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Yes,
Thank you,
ma'am.
ma'am.
Thank you.